What are regions? You may ask. So regions are essentially inequations. So typically you would have the equation y equals to x. In equations, you have the sign, the symbol bigger than equals to, smaller than or smaller than and equals to sign. That's if you were to sketch those inequations, you will get something called regions, right? You would have learned the line in methods already, so let's skip ahead to this one. It should be very simple. If I asked you to sketch y equals to x, you would get this line right here. But if I was to ask you to sketch y bigger or equals to x, then you would get the region right above. Why is that so? Let's just take a coordinates 0, 0. If I have the point at x equals to 0, my y value is equals to 0. However, for y value equals to 1, 2, 3, 2.5, they're all bigger than 0, so that's the point we need. So you will have this point right here, this point right here, this point right here, this point right here. They're all in the region. They all fit this inequation because 2 is bigger than 0, 1 is bigger than 0. And that's why we can't have -1. You can't have this point right here. It's not because that point does not fit this inequation. So that's why we shade the above region. Okay, moving on to the other region for line. Let's take a slightly different example. Y smaller than x. So now it's instead of bigger or equals to, it's just smaller than x. The one thing that you have to note here is there's no equal sign on this symbol, so we have to draw a dotted line. That means the region does not consist of this any points on this line right here. And of course, smaller than x means we just take the region underneath. And that's how you sketch a graph with regions. Okay, let's go on to harder examples, circles. So circles equations are usually, well, as such, you have x squared, you have y squared, you add them together, then you get r squared. However, this time, instead of equals to, we have bigger than sign or smaller than sign. Right, let's take an example. Basic circle, everyone's favorite. Oh, shouldn't draw it too big. Basic circle, right here. So we're taking x squared plus y squared bigger or equals to 1. So that means the radius is 1, the center is 0, 0. Ooh, -1, yep. Okay, so in this equation, we have a bigger than sign. That means we take the outer region. So you will see why. So we shade the outer region. I'll use this pen right here. Outer region is the required one for a bigger than sign. Okay, if you're ever confused, here's what you have to do. You sub in a point. Any point can be inside the circle or outside the circle. But since we want bigger than sign, let's just sub a point outside the circle just to illustrate this. Okay, so what's a point outside of the circle? So this is 1, 0. We can take 2, 0. So let's sub in the point 2, 0. So 2, 0 is somewhere here outside of the circle. If 2, 0, if you sub inside the equation, so 2 squared plus 0 squared, we get 4. If this number fits this inequation, so 4 is indeed bigger than 1, then that means that point, so that point 2, 0, is part of the region. That's why it's needed. So you shade that point. And then you can sub in -2, 0. You will still get the same thing, 4 bigger than 1. So -2, 0 is part of the region as well. And from that point on, you can just conclude that the regions required is the one outside. Okay, what about the region inside? So let's take another equation. X squared plus y squared smaller than 1 without the equal sign symbol right here. So just sketch a circle. However, like the line right here, we use dotted lines. So your circle should be a dotted line, not a solid line like these. So that's x squared plus y squared smaller than 1. So you can just chuck those numbers in. And center 0, 0. Okay, so you can prove it as well. You can just say, okay, I'm going to take a point inside the circle. You can sub in 0, 0 if you want. So that's 0, 0 is indeed inside the circle. If you sub that in, 0 squared plus 0 squared equals to 0. 0 is indeed smaller than 1. So this point, 0, 0, is inside the circle. It's part of the inequation. It matches. If, for example, you can sub in the point negative 2, 0, so that's outside the circle, you will get, so negative 2 squared plus 0, that is 4. That is not smaller than 1. So that is not smaller than 1, so it's not part of this inequation. So that's not the region you need. So that just basically concludes our region required is the one inside. Okay, moving on to ellipses. So ellipse and circle is very similar. I'll go straight into it. Let's just take a simple one. X squared plus y squared, and one of them over 4, the other one over 9, bigger than 1. This time I'll use an equals to as well, just to demonstrate the dotted and the solid line. Okay, so what does this look like? We have center 0, 0, so I'll take only simple ones because in the exercises you'll do the harder ones. And we have A, so A is the one under X, 2, that's the horizontal, and then B equals to 3, that's the vertical radius, right there. Right, how do we sketch this? Not that hard, we just have center here, add 2, add minus 2, then we have the center plus 3 minus 3, so that's what it should look like. An ellipse, there we go, good. And this one has an equal sign, so you just draw a solid line. Okay, which region do we need? It works the same way as circles. You can sub in the points if you want, but I'll just make it easy and fast for you. It's the region outside. It works the same way as circles. Of course, a smaller than 1, so a smaller sign. Let's just take the same graph. Y squared plus 9 smaller than 1 without the equal sign. What you have to do is, right, sketch your ellipse, then you shade in the area inside instead, inside of the ellipse, and make sure you have dotted lines. Okay, so that's with ellipse. Same as circle, it's not that hard, only different is the equation, slightly different. Okay, hyperbolas, this is the odd one out. Let's do an example and you'll see why. Right, x squared minus y squared bigger or equals to 1. What does that mean? Okay, so sketch the graph first. Your asymptote should be, so center is 0, 0. Always find the center first. A equals 1, B equals 1, and your asymptote is just y equals to plus minus, so x right here, and that's it. So that's your asymptotes. Right, okay. Proceed to sketch the graph as such, and that's your hyperbola. So we have a bigger or equals to 1 sign. Now, which region do we take? The one over here. So inside, not inside, but the one just to the left and right of your graph, or the one up right in the middle, right here. So you can always test the point. Sub in the points. Sub in 0, 0. That's the easiest one. If you sub in 0, 0, you'll get 0 squared minus 0 squared. That is equals to 0, which is not bigger than or equals to 1 at all. So that point 0, 0 does not match this inequation. So 0, 0 does not belong at all to this region. So that concludes, okay, it's not here. So let's try subbing a different point. I'll sub in a different point. Let's try 2, 0. So 2, 0 is somewhere here. We know this is 1, 0. So 2, 0 here. If you tried 2, 0, you would get, so 2 squared minus 0 squared that is 4. 4 is indeed bigger than 1, so that ticks and matches the inequation. So that's the region we need right here inside. You'll find out that the region is in, or not inside, but to the right, and you also have to the left. If you try solving in points, you'll get that. Okay, so with the smaller than sign, works just the opposite way. Get your asymptotes over there, and this time your graph should also be a dotted line. Yes, you'll have dotted lines and asymptotes going everywhere, but don't worry. And of course the region is just, oh no, the region is the outside region. So it does still go over the asymptote, as long as it doesn't go past this graph right here. Your hyperbola doesn't go past your hyperbola, it should be good. Okay, so that's all for regions.